Okay, yeah. Thanks, Atul, and welcome everyone. So this talk is about building observable AI agents. Rishi already has warmed up around agents and what all can go wrong. He has painted a rather grim picture at times, but he has also given a very nice overview of what all can go wrong and how. This is the flag of a very small country called Anguilla. Okay, very beautiful 3 dolphins on its flag, and that's its coat of arms as well. So, can any of you guess why are we talking about this very unknown country in this session? Any guesses?
Unknown content will be going to talk.
Sorry?
I mean to say like unknown thing will be going to talk.
Okay, that's very creative. Anybody else?
Any developer started the solution you have built must be from a developer from this country?
Okay, he is saying any solution that I am going to talk is from a developer of this country. Okay, that's rather very hopeful. The actual answer is that this country owns the .ai domain. Okay, so in 2023 they got 10% of their GDP just by selling the .ai domain, and in 25 they expect it to go to 47%. That tells us 2 things. The first thing is that Anguilla is a very small country and their GDP is also very small, okay. But that is not relevant to us. What is relevant to us is that AI agents are everywhere. We already saw one use case, what Rishi told us, and you all know, I believe, 10,000 other agents and their use cases. But the problem is that they suffer from silent failure problem. Okay. What is silent failure problem? Take example that I have quoted. It's a hypothetical example, but very realistic as well. On your website, your agent is freely telling users that a feature exists, a product exists, when it does not. It is hallucinating and it is doing so with confidence. Okay. No errors are getting logged anywhere, no alerts are firing, everything is hunky dory. Your monitoring is showing everything green, the system is healthy, but still the system is malfunctioning, it is giving wrong information to the users, and that is a failure. It is not getting logged anywhere. So, that is why we are calling it silent failure. I have mentioned this case study of medical multi-agent systems. What was found is that there was so you would have heard that we are now going to use AI in medical domain, and we also come up with the numbers that is 95% accurate, 92% accurate. So, researchers they looked at this a group of agents, they are talking to each other and doing detection, doing medical analysis, and it was found that 67% of the time the agents were hallucinating. They started talking to each other, they started well, and in the middle they just went off the rails, and somehow just by luck the final analysis was correct. Okay. And the researchers had to build a tool to actually analyze this. So, they had to use observability to understand what agents are doing. Even if the final solution is correct, they are just using a wrong way to reach it. So, this is the problem with traditional observability, right. Whatever we currently know about observability, what it does tell us? It tells us the payloads, uptimes, latencies, what tools are being called, what is the error rate, how many tokens are being used. All of this stuff you can easily observe, you can instrument, right. What it does not tell us is the critical part. Is the response accurate? How many times is it hallucinating? How confident would you be if your agent is hallucinating 50% of the times, right? You just totally cannot trust it, right? Is it meeting quality or safety standards? Is the reasoning correct? I do not know if you guys remember, couple of years ago Microsoft, before this GenAI thing started, Microsoft had released a chatbot. On the first day it was a very happy and helpful kind of bot giving nice answers. Within 24 hours this thing turned into racist and sexist thing, giving all sorts of conspiracy theories, because the real world is cruel, right. This is what people were talking to it. They were feeding it with all sorts of junk, and that's what it turned into. So Microsoft had done a good job training it on a good amount of data, but they did not realize that people are going to talk to it all sort of crap, right. So they forgot to put the safeguards that even if this thing is being subjected to bad information, it should not start spewing all that information, right. So quality and safety standards, that is, I think, paramount. Choice of tools correct, is the trajectory correct, is your agent taking optimal number of steps to reach the goal, a goal that it could maybe reach in 2 steps, is it taking 5 steps or 10 steps to reach, because that is going to increase your cost, that is going to increase the latency, that is going to reduce the performance. So traditional observability unfortunately does not give us this information. So what's special about AI applications? I think this is a very commonsensical thing. Traditional applications are deterministic. You have created a program, you give it an input, you get the output. You run this program 1 time, 2 times, 10 times, 10,000 times, you are going to get same output when you are giving the same input. That is not the case with AI or LLM based applications. They are probabilistic and non-deterministic by nature, right. You give it some prompt, you are going to get some output. You run this thing again, you give the same prompt, you may not get the same exact same output. You will get a similar thing, it will still be semantically similar, it will still talk the same thing, but the words may be little different, right. And that is what makes it difficult to assert the output of these AI systems, and that is what makes it difficult for traditional observability to be used with these. So since we are talking about agents, and to know what we are observing, we need to look at a little bit inside the agent. Okay. So what are the components? These are the 3 main components here. The first one is router. So this is like the brain of the agent. Okay. This thing determines which skill to execute based on user input, basically decides next action to take to reach the goal. So what is the goal? So whatever you have defined the agent with, the system prompt that you have given, okay, and that is the goal, and what the user is asking is another input in front of it. So the router will analyze the intent and context to route request to the appropriate skill, and this can be a very simple thing like a simple rules engine. If this condition, then do this, if that condition, do that, or it could be an NLP classifier. If your input and prompts are falling into this category, then do this, else do that, or like what is most common these days with AI agents, they use LLM. Okay. Depending on how much the complexity is, your observability requirement or observability style will change. Okay. Skills. So router was the brain, skills is the actual ability of the agent to do something. Okay. So skill is modular or reusable capabilities, and they will be chained to perform specific tasks, right. So each skill has got some ability, or it encapsulates a discrete function that it will do. So things like doing a vector search or a database search or calculation, making an LLM call, making an API call, code execution, DB search, all these things are different skills, different building blocks, and an agent can chain these building blocks to do some skill. For example, for RAG, it has to embed the query, it has to do vector search, and then finally it has to create the final output. So 3 tasks which are creating one skill, right. Then the state. So state or memory, also you can say that, this is one thing that separates an intelligent agent from a dummy agent which just takes input and gives some output. So if you guys remember the olden days, like 3 years ago, before AI agents came into picture, whenever you were on any website and you had a bot, you ask it something, it will give you a response. You ask something related to that, it has no context of that, right. It totally forgets what was the previous question, because it did not have memory, right. Even now, agents need memory. You will read this thing n number of times, that how much an agent is useful depends on how much memory it has got. It could be short term memory, it could be long term memory. So, most simplistically, memory is a shared state that is available to all the different components, to the routers, to the skills, and it contains whatever communication has happened till now between you and the agent. The previous messages, past observations, decisions that router has taken, skills, execution results, all of this stuff is used to maintain the context, right. And as you know, the context is everything for these AI systems. Okay, enough talk. I wanted to show you some demo. So, for this demo, I have made a very simple hand coded agent. It does not use hand coded means it does not use any frameworks, no LangChain, LangGraph, Crew, AutoGen, anything. It is just a simple Python code, and it has got one router for which I am using GPT-4o Mini, and it has got just two skills: look up sales data and analyze sales data. Okay. So, how this works, I hope you guys can see at the back. If not, I will just walk you through this. So, I will give some prompt to the agent, and agent is composed of router and the tool skills look up and analyze, and router is going to send that prompt to so basically router is going to get that prompt, and it is going to use its brain. Basically the LLM is going to help it decide what tool to call. So, my prompt is which stores did the best in 2021 and what was common among those. So, I have given my agent some Parquet file which has got sales data for some stores, and I am asking my agent to find which store did the best and what was common. So, there are two parts in this. So, router gets this query, it parses the query and it understands that okay, to find what was common I need to first find the data. So, it will first call the lookup sales data tool, and that tool in the yellow box it says create SQL table, generate query and execute query. So, first tool is going to do that, it will return the data, and then the second tool will take over, it will analyze data and extract insights and return. Okay. Okay, how do I switch to my terminal? Okay, Zoom now. I hope people at the back can see something at least. Yeah. So, I will also show you guys some code of this very simple agent. So, this is a sales data agent as I mentioned, and the job of this agent is to analyze and visualize the sales data that I have given to it. It is a simple Parquet file with a number of rows, and here is the system prompt for this. So, as I mentioned, each time you are creating an agent, you are giving it some definition, some personality, right. So, for my agent, the personality is a helpful assistant that can answer question about the sales data, and this thing is a direction to it. Use the tools available to you judiciously. Don't use a tool unless the user's request needs it, because otherwise agents just go crazy with tools. So, what are the tools that have been given to it? As I had mentioned, there are just two tools. First is this lookup sales data, whose job is to look up data, and the second one is analyze sales data. So, the data for the second tool is the output of the first tool. So, agent knows that there are two tools available and how they have to be chained. Okay. So, we will look at implementation of just one of these tools, not both. So, the first tool, the lookup sales data, what it does, it creates the table. If does not exist, it creates a DuckDB table, and it generates an SQL query to query the data based on the prompt. So, for that it uses LLM. So, I am using as I mentioned GPT-4o Mini. So, one good thing is that OpenAI now natively supports OpenTelemetry, right. So, this self client chat completions that you are seeing, this API uses OpenTelemetry and it will trace the calls with the span name chat completion. Okay. And then it will execute the query and return the data. So, let us look at how it shows up in Jaeger. So, I just ran one. So, I have in my code I have actually run these tools individually as well. So, look up sales data, if you see it takes the prompt as well as the tool output. Okay. So, this says generate an SQL query based on a prompt, do not reply with anything. So, this is the prompt that has been given to the tool and this is the output. So, it says select star from sales where store number is this. Okay. So, basically this is how the tool works, it takes some prompt and it returns some output, and here in this Jaeger UI we can see this. So, this is how individual tool works. I will show how it shows up in the agent. So, since this is a very simple agent, just got two tools, very simple prompt, this trace is looking decent, not very complicated, and we can see here, let me increase the font size. So, if you see here, this whole agent run span, and if you go and see in this one, you will see that first the lookup sales data is called and then followed by that analyze sales data is called. This chat completion is being logged by OpenAI. Okay. So, as I mentioned, OpenAI natively supports OpenTelemetry. So, it is going to log this. So, if we go in any of this, we can see the entire message history. I am sorry because I have increased the font size so much, it is not showing everything, but the entire message history. So, what happens is, as I mentioned earlier, the agent has to maintain the entire context. So, what all the messages are flowing across, the user prompt is there, the system prompt is there, the user prompt is there, the message from tools are there. So, all of this state is being captured in the traces. Okay. I am not going too much in detail in this because this is standard Jaeger. For this demo, I am also going to be using this tool called Phoenix. So, this is an open source tool which is OpenTelemetry compatible, it uses the same hotel collectors. So, currently I am using same collector and it is sending the same data to both Jaeger and Phoenix. Okay. This is an open source tool, as I mentioned, not yet part of CNCF, but they are in the pipeline, and it uses a protocol called Open Inference, which is also based on OpenTelemetry. What is the use of Open Inference? I will show you guys later. So, okay. So, we will try to wrap this up very quickly. So, this is the same UI that we saw in Jaeger, just a little bit differently. Okay. So, we have seen that we can trace all the information in Jaeger using OpenTelemetry, and the same thing in Phoenix as well, right. So, why are agents black box? We know that we have seen that agents hallucinate, and if it becomes until traditional observability does not help in observing them. So, what is the problem with these? So, the first thing is multi-step reasoning chains. So, unlike a microservice that has got a clear request response pattern, agent thinks in chain, right. So, like in this example, when I asked it to analyze data, it decided, okay, to analyze data I need data. So, for that I need to call this tool, and then I need to call that tool. For this simple thing, there were just two tools, but if you are using an MCP server, there could be hundreds of tools, and the agents just cannot handle this sometimes, because with the number of tools available, sometimes the definition of tools become very confusing for them. It is very similar, and so they cannot decide which tool to call. So, this becomes very difficult, and these multi-step reasoning chains, they become very, very hard to debug. And if something has gone wrong, how do you know what has gone wrong? Is it something wrong at step 3, something wrong at step 5, what is happening? Non-deterministic behavior, we have already seen that since LLMs are involved, you are going to get different output in different runs. Yeah. Complex tool usage. So, as I mentioned, with number of tools, as the number of tools increase, it becomes more and more complicated for this tool usage. Are the parameters getting extracted correctly if the tool is, or is the tool behaving correctly? So, we need to have observability into these kinds of things. This fourth one is the one I fear most. This is the emergent behaviors that traditional metrics miss. So, emergent behavior, I gave you example of that Microsoft agent, right. It was not supposed to be a racist, sexist bot, but it became, because that is how people were talking to it. Those medical multimodal agents, they were not supposed to be getting confused, but since they are talking to each other, they are getting confused, right. So, these sorts of emergent behaviors, or if the model shift, right. I am using GPT-4o today. Today's GPT-4o is going to be very different from GPT-4o of 3 months later, right. So, since the model's behavior is changing, your agent's behavior also may change. And silent failures, we already talked, they just hallucinate and are very confident while doing that. So, evaluation. So, what is evaluation? So, any LLM response can be of two types, deterministic and non-deterministic. What does this mean? So, deterministic is something like I say, I tell my agent, give me this data in JSON format, or for example, the first one which said generate SQL query, right. That is, you can verify that the SQL query is correctly formatted or not. Yeah, that is simple thing. You can use regular expressions, you can do that. But is the SQL query correct, as in is it doing what it was asked to do? That is something non-deterministic, right. So, deterministic things, you can compare output to the expected output, simple assertions. Yeah. Or if Python code, I ask my agent to generate Python code. So, is it generating a code that is runnable? That is very easy to assert. Non-deterministic things are difficult, and for that we use something called LLM as a judge. So, that is why this beautiful handmade image, yeah, not handmade. So, I do not know if you guys can see this at the back, but for LLM as a judge, think of an analogy that in your school, sometimes your teacher gave the class some assignment, and rather than checking it herself, she asked the top student of the class to check the copies, right. I know that I was not the top student, but could not do anything. And then the top student, usually she would be a girl, she would say that, here teacher, I have reviewed this submission as per your criteria, okay. And then the teacher would nicely hand over the submissions and the grades to us. Yeah. So, in this example, teacher is the user who is giving the prompt, the assignment to the student. Student is the agent, the model of the agent. Yeah. And model gives some output, some response, and since, as I mentioned, we cannot review the response for correctness manually, right. So, what do? We give that response to another top student. Who is a top student? Top student is a good model, high class model, Sonnet 4.5 or GPT-5, something like that, and we give it some criteria. What are the criteria? We will see with an example. So, that criteria could be, is the response correct, is it safe, is it matching the standards, those kinds of things, and this model would give us the response, and that is the review for the agent. So, we have seen what are the components of agent. Let us see what to evaluate in an agent. So, router is the brain, right. So, the first thing that has to be checked with this is, does the agent invoke the right tools for the task? Yeah. So, if there are 3 tools, for example, check order status, process refund, update for a customer support agent, is it choosing the correct tool for the given the user's prompt? Is it able to understand that it has got these tools available? So, that is something that you will have to check. Parameter extraction. So, suppose I ask my agent book a flight to Italy, is it able to extract the information correctly from this prompt that destination is Italy, mode of transport is flight, and does it then ask me for the information that is not available? What is your source place? When do you want to book it? So, those kinds of things. Skills. Yeah, Atul is asking me to finish, so I will be fast. Skills. So, we have evaluated the brain, now we have to evaluate the skills, and this is what your agent is going to return, right. So, this is what you have to evaluate. Is it relevant? Is it hallucinating? Is the response type correct? I asked it to generate Python code. Is it Python code or Java code? Is the Python code executable or not? Those kinds of things, right. So, different types of skills will require different types of evaluation. And then the state. As we talked earlier, is your agent taking optimal number of steps to reach the end, or is it making unnecessary calls to router, or are unnecessary tools being called? That is called convergence actually. So, we will check your state or agent for convergence as well. So, these are the 3 pillars of observability. You all know these: metrics, traces and logs. So, different metrics for AI observability, you can have latency, tokens, cost, things like those. Traces we have already seen, logs we know for debugging and all. For AI observability, you have to evaluate things like quality, accuracy, most importantly safety. So, what do you evaluate in an agent? Response relevance, accuracy scores, hallucination, things like those, convergence. So, once again we say hello to OpenTelemetry. So, we have already seen one demo where AI agent was hotel instrumented and it was sending the traces and eval metrics to the collector, and it was sending it to my Jaeger Prometheus, and we could observe all that in Grafana. Now, the 4th pillar comes into picture, AI evaluation, and that is where the AI Arise Phoenix comes into picture. So, that is where Arise Phoenix uses open inference. So, what is the advantage here with Phoenix is that not only it sends all these traditional traces or metrics, it stores these things, but also it uses this information to do the evals and use that evals, right. So, we will see a very quick demo in which I will show you very quickly how the evals look like. So, for this demo I will not be actually going to demo because of lack of time, but this is an agent that I created, and this time 3 skills: lookup, analyze and generate visualization using Python code. So, what are we going to evaluate in this? For the router, I want to check if this router is calling the tools correctly, right. There are 3 tools, is it calling them correctly, or is it randomly calling, or is it not calling, things like those. And this is going to be evaluated by an LLM. In this case, the LLM is GPT 3.5 Turbo. Then come the skills. The first skill, look up sales data. So, in this I want to check if the generated SQL query is correct. Then the second skill, analyze sales data. I want to check response for clarity, the end response that is going to the user, is this correct or not, is this clear or not. And finally, the Python code, check if the Python code is runnable. So, the first 2 will be evaluated by the LLM. The third one is very simple, Python code, if it is runnable, yes, we can simply check that in the code. Yeah. So, I will very quickly show you guys. Good thing that I have already have this. So, this is Arise Phoenix. I am sorry, I am not going into the code, but the code is shared later, so you can check that. So, this is how this thing works. So, you see these headings here: tool calling eval, SQL gen eval, response clarity, runnable code, etc. So, in my code I actually have got a bunch of evals, these 4 evals, where I am giving it some tasks, I am asking it some questions, and then I look at the responses and I send those responses to GPT 3.5 Turbo. I have given it some prompts. So, for example, I will just very quickly show. So, this is the prompt that is for the clarity eval. I am asking GPT 3.5 Turbo that okay, you are doing this, look at the response and your response should be a single word, clear or unclear, and here is the query, that is the user prompt, and this is the response of my agent, the GPT 4o mini LLM. Okay. So, GPT 3.5 Turbo is going to look at it and it is going to return this clear or unclear, and that is what is filling in this information about response clarity. Okay. So, currently this is a very simple demo. So, everything is 1, but if it is not clear, if the LLM is not giving good response, it will be given unclear, and these numbers which you are seeing as 1, they will go down. This number should be between 0 and 1, and it could be like 0.7, 30% times it was not clear. Runnable code, 20% of times the code was not runnable. So, this score is 0.8 and so on. And there is something called convergence also. So, like in this case you can see the convergence is 0.94. So, if I was running my agent with similar sounding questions, is it taking same number of steps to reach the goal, or is it getting confused and sometimes it is taking more number of steps, right. So, that is convergence. So, in this case convergence for 0.94, maybe some one time it took more number of steps, and that is where this score has come down. Okay. So, we have seen evaluation. So, now how does this whole thing fit into the resilience theme? So, we know that resilience is surviving any stress or any shock to the system and maintaining your SLOs, right. What is anti-fragility is that even after these shocks and stresses, your system does not go down, and basically it just improves. So, what I mean is that you have trained your agent with 1000 queries, yeah. 1000 first query is going to break it. Your agent is meant to say, is this you have trained your agent saying what are the features of my product. The consumer is asking how does your product fit against that product. So, this query may break your agent, but with anti-fragility, with this evaluation, your agent will now be trained. So, that is where in pre-prod you are testing your agent on your curated data sets, but in prod if it is going to get this totally googly kind of question, that is now part of your curated data set, and that is what agent is going to be trained. Once again it may be it may fail on the 2000 first query, but then again that will become the part of the curated data set and it will not fail again. So, we know that takeaways traditional observability is not enough, and for agents evaluation is observability, and OpenTelemetry is pretty good enough, but not 100% good for evaluation, and things like open inference, they are showing the path forward. Good thing is that OpenTelemetry is aware of these things. Their GenAI working group is working on the standardization of some of the things, and as I showed, OpenAI is supporting telemetry. So does most of the other LLMs as well as frameworks like LangChain, LangGraph, everything. So, the code is available here of all the agents, both the demos that I showed, the agent as well as the evaluation code, everything is available here. You can get it from here. Yeah, thank you guys.